everyone, and welcome back to my YouTube channel. Today, in celebration of gaining 10 subscribers as a new milestone, I will be explaining about how to solve limits to infinity. Now, you might have seen a function of a limit to infinity looking a bit like this. So this is basically saying that this is a limit as the value of x eventually reaches infinity. So x will be equal to 1 all the way to infinity, or even 0 all the way to infinity. And that will eventually become our value x. So when solving limits, it's very important that we understand that x is equal to infinity. Eventually, x will approach infinity, so we can directly say that x is equal to infinity. So the limit of this function would be positive infinity. And yes, there can be negative infinity. So an example with negative infinity would be the same thing, except it would equal negative infinity. So these are the first two rules of limits. Now, if we had a function as x approaches to negative infinity of x cubed, we would get negative infinity because negative infinity cubed is equal to negative infinity. But if this were a square, so if we write the same function except x squared, we would get positive infinity because negative infinity squared will become positive infinity. Just simple rules of exponents. Now, what if we had a function like this, but with positive infinity? Since there's no number greater than infinity, it would just be positive infinity, because positive infinity squared is just positive infinity, and this would work for any exponent. So even if this was 3, 4, or 5, we would still get positive infinity. Now, what becomes really interesting is when we take the limit as x approaches to infinity of the function 1 over x. So in this example, we can equate this to 1 over infinity. And since the number at the bottom will get infinitely small, we can say that this will continue on until it reaches approximately 0. So the value of this function would be equal to 0. This would also hold true for negative infinity, where if we have 1 over x, we'll get 1 over negative infinity, which would mean it is getting negatively infinitively small, so that'll be equal to minus 0, which is just equal to 0. Now, what happens when the number is greater on the top? So as you can see, here we have 1, and here we have x, which is equal to infinity. But what happens when x is on top? So if we have the limit to infinity of the value x over 2, that'll just be equal to positive infinity, because it is infinity divided by 2, which is still infinity because you can't divide infinity by anything. Now let's look at solving some binomial or trinomial fractional sums, or just any binomial sum. So if we have this limit, and we have 2 plus 3x squared plus 2x, what we will do here is we will cancel out all terms that are not relevant. So here 2x will not be relevant because 3x squared is much more relevant than 2x. So all those that are not really that relevant will be cancelled. So basically what we'll do is we'll take the term with the highest degree. So we'll solve to get this as a limit as x approaches to infinity for the function of 3x squared which is equal to 3 times infinity squared, which is just infinity. Now, what would happen if the degree on the top was the same as the degree on the bottom? If you can observe here, the same rule is applying, because this has a degree top of 1, and x here, which is equal to infinity, has significantly more value than 2. This also has a degree of 1, but x has significantly more value than 1, so it'll be equal to 0. But what happens if both of them are balanced? So if we have a limit as x approaches to infinity for the function 2x squared plus 2 over x squared minus 1. The first step we always have to do is cancel out irrelevant terms. That means that 2 and 1, because this is the term with the highest degree. So only take the term with the highest degree. So that means limit as x approaches to infinity of the function 2x squared over x squared. Now what we'll do is we'll multiply this limit into 1 over the highest degree of x in the equation, which here is 2. So we'll get 1 over x squared, and now when we divide both, we'll get the limit as x approaches to infinity for the function 2 over 1, which is just equal to 2. That is how you solve limits in this example. Now let's try a practice problem. I'll give you 2 minutes to solve it. Just write it down here. Okay, so what we're going to do here is we're going to solve it by saying the limit as x approaches to infinity of this function. First step is we're going to simplify it. Then we're going to multiply it into 1 over the highest degree of x, which is here 2. So when we do this, we'll get the limit as x is approaching to infinity of 2 plus 3 over x plus 2 over x squared over 1 minus 1 over x. So now we can simplify these terms and these terms to be equal to 0 using the limit rule. So we will solve this problem to be equal to 2 plus 0 over 1 minus 0. So if we cancel out all the zeros, we'll get 2 over 1, which is equal to 2. So this limit is also equal to 2. Now let's try another problem. We have the limit as x approaches to infinity of the function x cubed minus 2x over x. So now remember, the first thing we have to do is cancel out all irrelevant terms to get the function of x cubed, which is just equal to infinity cubed, which is just equal to infinity. Now, before I end this video, I'll just give one more problem. This will be a little more challenging. So this will be the limit as x approaches to infinity for the function of 2x4 plus x squared over 2x5 plus x minus 1. I'll give you guys a couple seconds to solve it. You can always pause if you need more time. So now the first thing we're going to do here, again, is to multiply by 1 over the highest degree of x, which in this case is 5. So we'll get the limit as x approaches to infinity, and the function 2x4 squared over 2x5 plus x minus 1 into 1 over x to the power of 5. So that'll make this equal to 2 over x plus 1 over x cubed. And that will make this 2 plus 1 over x power 5 minus 1. So, if we simplify this top part, we'll basically just get 0. So we'll get infinity for 0 plus 0 over 2 plus 0 minus 1. 0 plus 0 is just 0. 0 over 2 minus 1. So we'll get this equal to 0 over 1, which is just equal to 0. Anyways, that's about limits as they approach infinity. If you like this video and you want more math content, please like this video and please subscribe for more videos. Thank you.